Hello everyone, myself Sai Prasad, a lecturer in the Ahmedabad High School and the Junior College. Welcome to the series of the lectures of 10th class maths. We have started with the different concepts of real numbers, trigonometry and polynomials. Today we are going to discuss the important topic and one of the most easiest chapter, that is sets. What actually a set? What do you mean by the term set? Did you ever heard about the term set? Right? We heard about the different types of sets. We heard about what is a set in different constraints, right? We always take a pack of sets, we tell it as set of x, that is a dozen of x, right? It has a particular number, right? Is it clear? For example, if we consider the hair, do we have any count for our hair? If you can, but possibly this is taken as a bunch, isn't it? We don't have a particular count, right? Is it clear? Which means a set, whether it is a countable or uncountable, it has a fixed number, right? Is it clear? Which means we can define a set as a collection of distinct objects. Okay, we can define it as a well defined collection. Remember the term. The definition itself tells that it is a collection, right? Which means collection of some things, collection of students, collection of books, collection of pens or whatever, right? Similarly, you collect a few things such as chocolate wrappers, isn't it? That collection, is it clear? Collecting is bringing everything together. Then a well defined collection, is it clear? I am defining the kind of collection, wrappers of chocolate, chocolate wrappers, right? Uska collection, or else collection of your textbooks or collection of your whole students, right? We are defining it in a particular manner. We are giving it as a number, a 12, a 13 or 14 or whatever. Is it clear? That particular thing is called as set, right? Once again, let me tell. A well defined collection of any element or a distinct object. Clear? A well defined collection of distinct objects. What a distinct means? Different. Object is whatever it is, whether it is a chocolate wrapper or whether it is a student or whether pen or book or whatever. Clear? These particular objects, for example, if I tell objects are nothing but my markers, different colors of markers, it is also a collection, it is a set, isn't it? Let me write a set as some collection of pens. Let me write it as blue, red, black, right? Let me write it clearly, blue, red and black. Okay, these are three different objects. I have given a particular set to it, that is a set of pens. Is it clear? Hope you can understand. See here, this particular object is called as element, right? This is usually given as set ka name. Is it clear? There is a normal notation of a set. This is of capital letter and these are elements. If it is, for example, I have written the name something black or red, but most of the time remember, a set, the name should be always in the capital letters and the elements inside it should be always in the small letter. Is it clear? And try to remember, the whole set should be in terms of a flower bracket separating with a comma, that is this is one element, this is one element, this is one element, this is one more element, right? This is how we we give the notation for a set. Okay, then we can form, there are different kinds of sets. For example, I already told it can be countable or uncountable or whatever, or else simply you can remember is whatever the countable things are there, we can define it as a set. Right? Can we define a group of hair? No, it's impossible. Right? Can we define sugar as a set? No, it's impossible. Isn't it? We can define packets of sugar. It's possible. Right? Each packet. It might be some 1 kg or 2 kg or whatever. These are different kinds of examples of a set. When it comes to our practical mathematics, we shall have an example such as set of natural numbers. right? What are the set of natural numbers? From where does it start? It starts from 1, 2, 3 and so on up to what number? Up to infinity, I mean up to the last finite value. Then I have to define the whole thing in a particular set itself, right? How to define? Whatever set we do, remember it should have the initial value, it should have the final value, right? Which means this is a set of natural numbers. I am starting from 1 and I have to specify that it should end at a particular point, right? Then I can write it as a natural number can be written as x such that x is a natural number and x less than 15. Is it right? Can I write like this? What do this mean? X is my natural number. What is that x? X is a natural number, right? He is telling that x is a natural number and he also gave a condition that x should be less than 15. What are the different natural numbers less than 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and up to 15. Is it right? Is it clear? He is telling x is less than 15. Less than 15. Which means 15 is not included. Remember this term, that's why I have written it again. Is it clear? The set ends till 14. Hope you can understand this kind of thing. If I tell x is less than or equal to 15, then I can include 15 here. Now I gave only less than. Is it clear? Hope you can understand. This is one way of representing and this is one way of representing. Right? This is still more simplified and generalized way. Right? This form is called as set builder form. Remember, this kind of format is called as set builder form and this is roster form. Is it clear? A set builder form, the name itself indicates that this set can build, right? This notation can build a set, right? In most of our textbook, this x such that is always given as like this, right? X such that, remember the term such, S-U-C-H, that, T-H-A-T. You have to write this as, you have to pronounce this as x such that x is a natural number and x is less than 15. Is it clear? It requires two things. One is the condition and one more is limit. Is it right? Hope you can understand up to here. Right? Then let us have few examples of sets. See here, let me have set of even numbers. How to write? Set of, let me write it as E. X such that x is an even number and we have to give the limit, right? X is less than 21. What are the different even numbers up to 21? We can write it as 1. Is 1 an even number? No. 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Right? These are the different even numbers less than 21. Is it clear? This can also be represented in another form, that x such that x is equal to 2n. Right? Even number notation 2n. What is n? 1, 2, 3, 4, 5, 6 up to some number. 2 1s are 2, 2 2s are 4, 2 3s are 6, 2 4s are 8. Right? Then we have to define this 2n. What is 2n? We can write it here directly. X equal to 2n such that x is, what is, we have to define this n here. N is natural number less than 11. We can define it. See here, we are getting up to 20. That is 2 into 10 is 20. Less than 11 is 22. Okay, even if you don't understand, try to understand this. X has that x is an even number and x is less than 21. What are the even numbers is 2 to 20. What the form this is called as? This is, once again let me tell, it is set builder form and this is roster form. Hope you can understand this, right? Now let us do a few examples of your textbook. Now see here, these are different examples. These are in the roster form and these are in the set builder form. Okay, these are the examples from your textbook. He is giving A, E, I, O, U. You would have heard about this. What are these? These are vowels of a English alphabet. That is, we have 26 letters. Among those, these 5 are vowels and remaining 21 are consonants. Right? Then he writes the set as X such that X is a vowel in English alphabet. Is it right? Is it clear? The next thing is minus 2, minus 1, 0, 1, 2. We can directly define it as minus 2 to plus 2. We can define it as the numbers from minus 2 to 2. Minus 2, minus 1, 0, 1, 2. Right? Are these natural numbers? No. There is 0, minus 1 and minus 2. If it is from 1, we can directly write it as natural number. These are completely real numbers which lies between minus 2 to 2. Okay? How to generalize is X such that minus 2 less than or equal to X less than or equal to 2 and X belongs to Z. What is Z? Z is set of integers. Is it clear? Where X lies between minus 2 to 2. Right? I have specified here less than or equal to, which means this number includes minus 2 and plus 2 also. Hope you can understand. Right? Let us move on to the next. What is this? 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Right? Can I write this one also 1 by 1? Isn't it? Can we write right? Therefore, only the denominators are increasing. What are the denominators? They are nothing but, what are those? They are natural numbers. Is it clear? This is nothing but 1 by n, where n is increasing in natural way from 1 to 5. This is nothing but that. Right? X such that X is equal to 1 by n, where n belongs to natural numbers and n is less than or equal to 5. Is it clear? If I don't want to write this equal to, just I will remove this and I will write it as 6. Can we write? Similarly, the last thing, that is 2, 5, 10, 17. If you observe, you have to formulate this kind of things. We will discuss about how to write this thing for this kind of set in our progression kind of chapters. Okay, see here 2, 5, 10, 17. These are just the next number of our perfect square numbers. That is 1 square is 1, add 1. 2 square is 4, add 1, it will become 5. 3 square is 9, if you add 1 it will become 10. 4 square is 16, if you add 1 it will become 17. Right? That is nothing but X is equal to n square plus 1, where n belongs to natural numbers and n is always less than or equal to 4. Right? Up to 4. 4 square plus 1. Hope you can understand, right? This is what, these are different kinds of roster forms and set builder form. Is it clear? Shall we move on to the next concept? Let's do that. Let us start with a few exercise problems. See here. Here there are 3 sets given. Hope you can remember everything. See here. There is a capital letter and these are the small letters. Right? Inside, always the element should be in smaller size, and outside the name of a set should be always in the capital case. Is it clear? Which means this should be in the lower case and this should be in the upper case. Hope you can understand that. Now he is asking whether 0 belongs to A or not. Right? Is there an element 0 in A? Yes, it is there. Then we have to write it as 0 belongs to A. This is a symbol of belongs to. Remember, belongs to, it indicates this is a symbol. Is it clear? If it tells it does not belongs to, then let us see what it will be. 3C. Where is C? Here it is a set C. Is this 3 in the set C? Do we have 3 in this third set? We don't have. Therefore, we write it as it does not belongs to. Right? It is similar to equal to and not equal to. Is it clear? There is also one of the symbol. Is it okay? Hope you can remember. The next, P and C. This is small p. Don't get confused. Again, we'll discuss in our regular class. P and C. This P Does it belong? Does it a part of set C? Yet, yes, it belongs to C. What about 7? Is 7 is there inside B? Yes, it is there. Again, it belongs to B. Is it clear? Shall we move on to next problem? See here. He is asking us to write this particular set in set builder form. In which form is it? It is in roster form. Then we have to write it in the set builder form. How to write? First of all, before writing that, we have to check what are the terms 3, 6, 9 and 12. What are those? Right? 3, 6, 9, 12. Is there any common connection between these four? Yes, there is a common connection. What is it? 3, 6, 9, 12. Right? Or as you can write it as 3n. Right? Where n starts from 1, 2, 3, 4. These are the table, 3 table, isn't it? Let us write like that. This is x such that x is equal to 3n, where n is a natural number. N is a natural number less than 5. Is it right? N is a natural number less than 5. What are the different natural numbers? 1, 2, 3, 4. Let us substitute and verify it. 3 into 1, 3. 3 into 2, 6. 3 into 3, 9. 3 into 4 is 12. And he is telling less than 5. Then we will not write 5. Only 4 numbers. Is it right? Let us move on to the next. 5, 25, 125, 625. Right? Is there any common connection between these? You can verify. 5 5s are 25, 25 5s are 125, 125 5s are 625. Once again, let me see here. 5, 1, 5. 5 square, that is 25, that is 5 into 5. 5 cube, that is 5 into 5 into 5, 125. Again 5 power 4, 5 into 5 into 5 into 5. Right? That is 625. Therefore, I can write it as x such that x is equal to 5 power n. Can I write like that? Or you can write in the word format as the powers of 5. That is where n is a natural number less than 5. Again, isn't it? We are getting the same thing. 5 power 1, 5. 5 power 2, 25. 5 power 3, 125. 5 power 4 is 625. However, will not take 5 because he is telling less than 5. Okay. The next is 1, 4, 9, 6, 25 up to 100. 1 square is 2 square 4, 3 square 9, 4 square 16, 5 square 25 up to 100. Kiska square will be 100, 10 square will be 100. Therefore, I can write it as x such that x is equal to n square, where again n is a natural number less than 11. Right? To make it more comfortable, let me start from this. This can also be written as x such that x equal to n square, where n belongs to capital N, n is less than 11. Can we write like that? This is also simplified version, that is also set builder form. You can write in any of the way, whichever it is comfortable for you. We can even write for this, instead of writing this whole, we can write it as n belongs to n and n is less than 5. Here also n belongs to n and n is less than 5. That is also kind of set builder form. Okay, let us move on to the next problem. Here, what is the question given? X such that x is a natural number less than 6. What are the natural numbers less than 6? 1, 2, 3. Right? That's it. Let us write everything. 1, 2, 3, 4, 5 and 6. Is it right? Now let us move on to the next problem. That is x such that x is a prime number which is a divisor of 60. Right? Okay. See here. What are the divisors of 60? That is, what are the factors of 60? What are the factors? Again, without these basic things we can't do anything. What are the factors of 60? 1, 2, 3, 4, 5, 6. right? 7, 8, 9, 10, yes, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? The next is 30, right? These are different factors, right? What are the prime numbers among them? 1, 2 are neither prime nor composite. 3 is a prime, right? 5 is a prime. 4, 6, 10, 12, 15, 20, 30 are those primes? No, they are not at all. Therefore, the prime numbers which are divisors of 60, what are those? They are nothing but 3 and 5. There is a set, that's it. Isn't it? Next, he is asking x such that x is an alphabet in better. What are the alphabet? What are the different alphabets here? 1b, let us write. 1a. Next, 1t. There is only 1t. Even if they write many times also, we have only 1t. E is already covered. The next is r. These are the set of alphabets in this word. You can even write in your name. Isn't it? Let us consider maths. M-A-T-H-S. There are 5 elements. Is it clear? This is how we will do the basic problems of sets. What all we discussed? We have started with the definition, right? We have discussed the different types of sets. We have discussed set builder form, the roster form, whether the element belongs to the set or not. Is that clear? Hope you can understand. In the next session, let us start with a different subsets, union, intersection and kind of thing. Okay, is that clear for today? Right, let us meet in the next class. Thank you.